Hey there, today we're going to look at rotations. This is the third type of transformation that we have. And a rotation, there's a couple things that you're going to have when you're rotating. You're going to have a point of rotation, some spot at which you're going to rotate things by. And it's almost like that spot is attached to, in this case, your triangle. And then it just moves that point a particular angle. That angle measurement's the other thing we're going to need to know. We need to know where to rotate from. We need to know how much to rotate. So you would take this, you're going to draw this line, you're going to see how much you want to rotate it, measure it out, and then make sure this distance stays the same as this distance. This is a rigid transformation. All the distances are going to stay the same. Now once you do V, then you'll do the same thing with the other points of the triangle. Let's try one. All right, first of all, some notation. It's a rotation. We use a lowercase r because a capital R is a reflection. Lowercase r means you're going to rotate a certain number of degrees around a particular point of some triangle. And after you've rotated that triangle, that becomes your image. Okay, we do rotations always counterclockwise. That means going around, well, like you're measuring with a protractor. When you have a protractor, and this is going to be important, when you have your protractor here, and you have some sort of hole right here, that hole is going to go on the center of rotation, and you're always going to line it up on the right side over here. Never use the left side. In fact, I'd almost like it if you put a piece of tape over there, like masking tape, hide it. Don't use the left side. Always using the right side of your protractor. All right, so this is a little bit tricky for me to show you how to do this in a video because I know you can't see the protractor, but I'm going to do my best. Here we go. What is the image of a rotation 100 degrees around point C of triangle LOB? All right, here's the first thing you're going to do. You're going to start off and do this with me. And I'm going to color code this so you can see because we got to do the same thing over and over on this. I'm going to begin and I'm going to draw a line from my point of rotation to one of the points. Let's go ahead and let's just draw it to point B. Now, that line is going to rotate around point C, and it's going to rotate counterclockwise. It's going to go this way. So what I'm going to do is I'm going to take my protractor, and I'm going to put the hole of the hole of the protractor right here on point C, and it measures off the line to the right. Now, it might be smart when you draw this line to make this plenty long. Sometimes I extend it so that when I put my protractor up there, I can really line that up really well. So I can tell way out here to the right that it's at 0. Now, if you're using my protractors, we're going to be using the lower numbers. You have numbers on the outside and you have numbers on the inside. We're using the inside numbers because the inside number over here on the right is 0. And then you'll see a 10, 20, 30. Okay, 10, 20, 30, 40, 50, 60, up to 90. You're looking for a 100. So with this protractor lined up like this, you're going to mark off a 100 somewhere out here-ish. Then you're going to go ahead, once you mark the 100 degrees, go ahead and draw the 100 degree line there. All right, so now you know how far to move point B. Now you need to know how long that's going to be. So you're going to take your compass, and you're going to put the point of your compass right here, and you're going to measure how far it is to B. Now I'm going to be looking for a little arc there that you measured. Oh, right here is how long it is. And then I swing that up there and put the point, keep that point at C, and I transfer that same distance over here on this line. And that spot right there becomes my new B prime. So I just took B and I rotated it 100 degrees. Okay, now I'm 1/3 done. I'm going to do that 3 times. I have to do it with O and I have to do it with L. So let's try again. I'm going to change colors. If you want to change colors, that'd be great too. I'm going to work on L now. So I'm going to draw my line from C to L, and I'm going to draw it plenty long so I have something to line my protractor up with. Okay, now I put the hole of the protractor right here at C, and I line up the right side of my protractor right here and try to make this land on your 0 line over here. And then you're going to see 10, 20, 30, 40, 50, up to 90 over here to a 100, somewhere out there. Put a little line at 100 and then draw that. So you know how far you've rotated it, 100 degrees. Now you have to measure how long is CL. So I'm looking for this arc up here that you measured. Remember your point of the compass at C, measure that arc to L, transfer that distance over here, and that's your new L. That's L prime. All right, let's try one more time. Now we're going to draw from C to O, but extend it plenty long. The hole of the compass goes here. This goes along the right side of your protractor, measuring it up, lining it up with 0. And then you measure 100 degrees, which is here-ish, kind of making that up. I'm going to go a little bit farther. Sorry, don't use that. Right here. And then you draw your line. Measure how long it is from C to O. Transfer that distance, C to O, right here. That's a little long. I'm going to make that a little bit shorter, I think. Right there-ish. Maybe it looks better. All right, and then that's your O prime. Last step is to go ahead and connect your 3 points. Now I just freehanded this, so don't judge me too harshly there. That's my image. And that's the one that I want you to use a highlighter on or a red pen. Make that stand out because I'm going to grade this with my overhead sheet and lay it right on top of that, and hopefully it matches right up. Okay, rotations take a little bit more time, no doubt about it. Okay, let's try this one more time. This will be a little bit easier of a problem. They want us to rotate this around point D, and they want us to rotate it 180 degrees. So I'm kind of seeing that in a couple places. We're going to rotate about point D. We're going to rotate it 180 degrees. We're going to use our prime notation to label the new image. Okay, this is actually easier. If I'm going to rotate it around this point D, it's almost like you put a pin right there, and that does not move, and A and B will rotate around. So that's nice because that means that D is going to be the same spot as D prime. That's not going to change. But this B now, where I'm going from D to B, if I rotate something 180 degrees, it's going to go straight across the opposite way. So instead of it going out this way to B, it's going to be going the exact opposite way. Well, that's pretty easy to draw then. I would just line my ruler or protractor up right here on this line and just extend it out. So I'm going to go like, and then I'm going to measure how far is it from D to B, transfer that over here, and that's my B prime. Now I'm going to do the same thing with R. If I wanted to go towards R, it goes this way. 180 degree rotation is going to go exact opposite way. Let's draw that in there. It's going to extend this way. Use your ruler to draw that. And then you're going to measure from D to R, transfer that up here, D to R, and that becomes R prime. And remember what we said about D? D, it just rotates around D, so D and D prime are the same point. So I think I'm ready. I've got my triangle. Boom, boom, boom. Highlight it or use a red pen, and you've got it. Now, if I'm going to rotate something on a coordinate grid, and I'll do this a little bit where I'm using very special angles, like a 90-degree angle, or a 180, or a 270, or 360. So that's just kind of a rotation of an additional 90 degrees each time. If you do that on a coordinate plane, special things happen. Let's look at what happens. I'm going to kind of bounce around here a little bit. If you rotated 180 degrees, this is what we just got done doing. If I take, and I'm always going to be rotating off of the origin, so that's something extra to remember here. I'm just going to always keep it simple, just go from the origin. Whatever my coordinate is this direction, if I rotated 180 degrees, it's going to be the same numbers, only the exact opposite sign. And so this 2, 3 becomes -2, -3. All right, so you can see there's a rule here, and we'll use this for our rules. But for your x, y, all that happens is the signs change. If my original point was a negative, negative, then it's going to be a positive, positive. So you just change whatever sign is on the original, you change the sign of it and put it in here. Okay, that's if it's a 180. Let's talk about if it's a 360. Well, if you think about it, it's a 360, it's going to rotate all the way around, it's going to land right where it was. So that's not rocket science. Your ordered pair will stay exactly the same if you rotate at 360 degrees. All right, the trickier ones are your 90 and your 270. Because if you have a particular ordered pair and you're going to rotate it just 90, it's going to kind of change quadrants on you here. And what happens every time is that x and y swap. See how it's a yx? Same thing here on the 270. The xy turns into a yx. Now, not only does that happen, but you can see also that one of the signs will change. So the x turns into the y, but when the y becomes the x, you also have to change its sign. So looking here, the x becomes the y, but then the y, when it becomes the x, you change it to the opposite sign. When you do your 270, it's the other way around. The y directly becomes the x, but when the x becomes the y, you have to change its sign. So again, the y becomes directly the x, but when the x turns into the y, you have to change its sign. All right, so you can just use this to help you with that. I'm going to ultimately give you kind of something like this, a point, and you have to tell me your new coordinates on it. Let's try one. All right, this says that I'm going to graph at a 270-degree angle. Okay, so I'm just going to write this here for us. For the 270, the rule was that an xy is going to map to a y negative x. All right. So when I look at these points, if I want to graph this rotation, I'm just going to look at ordered pairs, and I'm going to fix all of my ordered pairs. Let's start with f. F is -3, 2. So looking back up here, the y value is going to turn into the x value. So the 2 is going to turn into the x value. And then the x is going to turn into the y value, but you have to trade its sign. So it's going to be 2, 3. So let's plot that point, 2, 3. Okay, so if I rotate it, that's going to be my new f. All right, and that's all we're doing. Let's go through every point and do that. Here's G. The y becomes the x. The x becomes the y, but you change its sign. Plot it, -1, 3. Here's G prime. All right, let's do the H. The y becomes the x, and then the x changes its sign and goes to y. -1, 1. Here's my H prime. Last one, I. The y becomes the x, the x becomes the y, but it changes sign. But a 0 doesn't have a positive or negative, so it's just going to stay a 0. And then I'm going to have over 1 up 0. So there's my new I prime. Okay, probably should have used a different color there, but ultimately here is my new picture then, my new quadrilateral. Looks like this, after it has been rotated 270 degrees around the origin. Okay, and then the last type of rotation that we'll come across, and this is kind of cool. It's going to rotate. It's any kind of a polygon that we've learned. This particular one is a nonagon. If you'll recall, a nonagon has 9 sides. And I'm going to sit there and rotate it around its center. Well, if it's a regular nonagon, all these points are going to end up landing on top of each other as it rotates. So that's kind of slick. Now, the question here is to find the angle of rotation that would map point F. And remember that we always rotate counterclockwise. So we want to rotate F clear over to H, it says. All right. How many degrees would that have to be? Well, here's my steps for you to do that. It says, what's the measure of each central angle? The central angle is the angle right here that would go from F and then to E. What is that angle right there? Well, it's 360 all the way around, and I know that I've got 9 points on this polygon, so all I really have to do is take 360 and divide it by 9, and that would tell me each one of those angles, and that actually came out nice to 40 degrees. Okay, so that's a 40-degree angle. The next question is, how many times do you have to rotate that? Well, let's look. I'm trying to get F clear over and around to H. So here it goes. It would be 1, 2, 3, 4, 5, 6, 7 times I'd have to rotate that. So I'm going to rotate 40 degrees 7 times. 40 times 7 is 280 degrees. That's how much I'd have to rotate it to get F to land on top of H. All right, so I'm going to call that quits on your notes here. I know that there's a little bit more in your notes about tessellations. That's really something that you're going to have to talk to me in Encore about. It doesn't take very long, but it probably needs some one-on-one instruction with that. So that's all I've got for rotations for you. Good luck. Your homework is going to be on a worksheet. It's not on Math Excel. Do the worksheet.